Alright, in this video here we're going to talk about solving equations graphically using method number 2, which is the intersect method. Now, I did another video where I described the two different methods you can use to solve an equation graphically, so if you haven't seen that yet, I would suggest you check that out because I go through like step by step. This is method 1, this is what you have to do. Method 2, this is the steps you have to take to solve it. In this one I'm just going to do an example problem where I use method 2 to actually solve this equation graphically. Right, so method 2 is called the intersect method, which basically means I need to graph two equations and then find the intersection of those two graphs, right? Find the point where those two graphs cross or intersect each other, right? So the reason I like to use the intersect method as opposed to the x-intercept method is because for this intersection method, I don't have to do anything with my equation to start. Just whatever my equation looks like, doesn't matter. I just take the left side of the equation. That's going to be my first equation, my y1, that I graph. The right side of my equation, that's going to be my second equation that I graph, the y2. Right? So if I go to my calculator, I go to my y equals screen, and I already typed these in just to save us some time here. So my y1 is the 5 minus 3x. My y2 is 8x minus 20. So I type those two equations in there, and then when I hit the graph button, I get the graph of those two equations, right? So that's what my graph looks like, and that point where those two graphs cross, it's kind of hard for me to do this here, but that point up there where the two graphs cross, that's going to give me the solution to this equation. All right, so let me just quick up here draw what this graph looks like, more or less. So this one's coming up like that, and this one's coming down that way, and they're intersecting right over there in the fourth quadrant somewhere. All right, so now I need to find what that point is, and that point is going to give me my solution to this original equation up here. All right, so now an important thing when you are using your calculator or another graphing tool to solve by intersecting, you have to be able to see that intersection point on the screen, right? If you graph these two equations, and just to give you a kind of a side note over here, if you graph the two equations and one of them's a line going like this and the other one's a line going like that, and they don't quite meet up, you can see like if they keep going over here, they're going to intersect eventually. But if you don't see that intersection point on your screen, you have to change the window of the screen that you're looking at using this window button up here. If you have a TI-83 or 84 calculator, it's right above my finger there. Right, you can use that window button to make your X values bigger, make your Y values bigger until you actually have that intersection point on the screen, and then your calculator will tell you the coordinates of that point for you. All right, so in this case, though, it's on the screen already, so I can just go ahead. And by the way, the screen I'm using here is the standard window, which if you hit the zoom button and then number 6, right, that's the standard window, which is the X values go from -10 to +10. The Y values go from -10 to +10 as well. Right, that's what we call the standard window on these calculators. Right, so I have my graph there. To find the intersection point, just like when I did the video for method 1, which was the x-intercept method, I go second and then the trace button to get to that calculate menu. Right, so the calculate menu has a whole bunch of things. To do the x-intercept method, which was what I did in the other video for method number 1, we would choose number 2 here, which is 0. Right, but for this method, which is the intersect method, I would choose number 5, which says intersect. Right, I need to find the point where these two graphs intersect each other. So I choose intersect, and in this case, it doesn't ask me for like a left and a right bound like when I have to do the x-intercepts. It just asks me for the first curve. And notice up here it tells me that it already has the cursor on the y1, so I just have to hit enter. It asks me then for the second curve, but again up here it tells me that it already has the cursor on the y2, so once again I just hit enter. And then for a guess I can just hit enter again, and it doesn't take very long and my calculator puts the cursor right on that intersection point, and then you can see down at the bottom it tells me the x and y coordinates of that intersection point, right, which I cannot see that when I'm looking at it through the camera there, so let me write this up here. Right, so my intersection point, x is 2.2727 repeated, it looks like, so 2.27, and then y is -1.8181, looks like also that's repeated, -1.818, let's say. Okay, so that's my intersection point. Right, so I get the x and y coordinates of that intersection point. Now the question is, which one of those is the solution to this equation? Right, the answer to that is the x coordinate. Right, remember this equation was in terms of x, so I'm looking for the x coordinate here. That gives me the value of this equation, or not the value, that gives me the solution of that equation. right? So if I plug in x equals 2.27 to both sides of the equation, they will be approximately equal to each other, right? They're not going to be exactly equal if I plug in 2.27, because remember, that's not the exact solution. I had to round that off. So it's just an approximate solution. So if I plug that back in to both sides of the equation, what I'm going to get on each side when I plug that number in is the y value over here, negative 1.818, or something very close to that, again, since I'm not plugging in the exact solution. But the x value represents the solution to the equation. The y coordinate of that intersection point represents the number that I would get on each side if I plug that x value into both sides of the equation to check it out. All right, so that is the intersection method of solving an equation graphically. And it's not that hard to do. I mean, you have to type in the two equations. You have to draw the graph of it. The hardest part is, like I mentioned before when I drew that little thing over on the side, if that intersection point is not on the graph, sometimes you have to play with the window in order to see where the two graphs actually cross each other, which sometimes that's easy to do. Sometimes that can be a little bit more of a pain in the neck to actually, sometimes you have to change the numbers and you look at it and you still can't see the intersection point, so you have to go change the numbers again. And sometimes it's like a back and forth thing until you finally see it. Some types of equations, depending on what they are, like if these two are just two straight lines, so they're only going to have the one intersection point. But if one of these was like a curve, something like this, it might intersect that line, 2 or 3 different times. So you have to make sure you find all those intersection points on your graph to make sure you get all the solutions to the equation, right? So for me, a lot of times, especially for one like this, for me, it would be easier to just solve this equation algebraically, subtract the 8x, subtract the 5, divide by whatever that number is, and get the solution that way. I could probably do that a lot quicker than what it took me to do all this stuff in the calculator. But for other types of equations, solving it graphically is definitely going to be quicker and easier than solving it with some of the algebraic methods for some of the, the more difficult types of equations that you'll see. All right, so that's your intersection method. The two sides of the equation are your y1 and y2. Graph them both, find the intersection point. The x coordinate is your solution, and that's really all there is to it.